The P versus NP problem is one of the most famous unsolved problems in computer science. And it's so important that the Clay Mathematics Institute has named it one of the 7 Millennium Prize problems, and offers a $1 million prize for its solution. To understand this problem, we first need to understand what P and NP are. In computer science, we often want to solve problems with computers. And we're interested in how quickly we can solve these problems as they get larger. For example, if you're trying to find the shortest route between two cities on a map, the problem gets harder as the number of cities increases. We classify these problems into different categories, based on how quickly we can solve them. The class P, which stands for polynomial time, is the set of problems that a computer can solve quickly. More precisely, a problem is NP if there is an algorithm that can solve the problem in a number of steps. That's a polynomial function of the size of the problem. For example, if you can solve a problem in 10n2 steps where n is the size of the problem, then that problem is NP. The class NP, which stands for non-deterministic polynomial time, is a bit trickier to define. A problem is in NP if whenever the answer is yes, there is a quick way to check the solution. More formally, a problem is in NP if a solution can be verified in polynomial time. For example, if I give you a route between cities and claim it's the shortest, you can check my claim in a number of steps. That's a polynomial function of the number of cities. Now, it's clear that every problem in P is also in NP. If you can solve a problem quickly, you can certainly check a solution quickly. Just solve the problem and compare your solution to the one you're supposed to check. The big question, the P versus NP problem, is whether the reverse is true. If a problem is in NP, i.e., solutions can be checked quickly, can the problem always be solved quickly? In other words, is P the same as NP? This might seem like a technical question, but it has huge implications. Many important problems are in NP but aren't known to be in P. These problems, known as nitrogen monophosphide complete problems, include many practical problems in fields like logistics, circuit design, and scheduling. If it turned out that P and P, and we found a quick algorithm for one NP complete problem, then we'd have a quick algorithm for all of them, which would be a revolution in computer science. On the other hand, if P NP, that would mean there are problems for which no quick algorithm can ever exist, no matter how clever we are. This would have implications for fields like cryptography, which relies on certain problems being hard to solve. Despite decades of effort, no one knows whether PNP or PNP. It's one of the biggest unsolved problems in computer science, and solving it would be a major breakthrough.